Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Okay, so you have a quadrilateral and you're supposed to come along and prove it's a parallelogram. How can you do that? Well, the answer to that is whichever way fits your scenario best. And there are at least 5 options that you can do. So one, you could just show or prove, depending on your information, that these sides are parallel. And then you could show or prove that these sides are parallel. So that's option 1. Okay. Show/prove 2 pairs parallel sides. Okay, well, what if I don't have that information? Okay, that's fine. The next thing you could do, your next option, is you could show that this is congruent to this, and this is congruent to this. So if you can show or prove 2 pairs congruent angles non-adjacent. We need the opposite angles, okay? They need to be opposite or non-adjacent. Okay, so that's the second way. Well, what if you don't have that information? Okay. If you can show or prove that A plus B equals A plus C and that they both equal 180, that would be a third way. Because technically what you're doing there is you're proving 2 pairs of parallel lines, and that's why it works. So you have to have that congruent supplements, but you have to have it based off of one vertex and its adjacent angle to each side. Okay, so that's option 3. Option 4. I need to draw better diagonals, don't I? Option 4, you could show or prove that the diagonals bisect each other. In other words, this top half and this bottom half are congruent. This left side and this right side are congruent. So you'd have to show both of those things, which means you would need to know the length of the 4 lines somehow, some way. Or finally, option 5. If you can show that one pair is both congruent and parallel, then you'll be safe. So that would be sufficient. Show one pair of segments to be parallel and congruent. So if you have any of those 5 options, you have a parallelogram. It's up to you which method is best in your situation. And they can all be proven, and they'll all go back to triangles, and corresponding parts of congruent triangles are congruent, and all that stuff, so that we can make our parallel lines. So you don't have to prove why these theorems work. Knowing that they work is great. Knowing that the rules work is great. You just have to be able to use the rule and do that. So any of those 5 is sufficient. So I'm going to draw a couple parallelograms, and we're going to decide if we can prove it and why. So remember, the picture could be off. Picture probably is off because I freehand, and I know I don't freehand well. All right, we have 27 degrees, we have 153 degrees, and we have 153 degrees. How would you like to prove that is it a parallelogram, and if so, why? Well, we have a couple ways we could do it. We could either remember that quadrilaterals have to add up to 360, and we have 153 plus 153 plus 27. We're only at 330. That's also 27. And we would have congruent angles and congruent angles, therefore yes. But the way that this is written just encourages us to go 27 degrees plus 153 degrees is 180. So that tells us that these lines are parallel, because parallel lines cut by transversal, right? So angle A plus angle D equals 180. Angle A plus angle B also equals 180. So therefore, we have, the congruent supplement theorem, number 3, right? So because of that, yes, we have a parallelogram. So when angle A plus angle D equaled 180, that told us these sides were parallel because the consecutive interior angles added to 180. When angle A plus angle B added to 180, it told us these sides were parallel because of the congruent supplements theorem. And therefore, or the same side supplements, same side interior angles, and therefore we have a parallelogram. It all goes back to any of your rules about two lines cut by a transversal, because that's what we have here. If you ignore this line right here, we have two lines cut by a transversal. Can you show they're parallel? Absolutely. Okay, so I have parallel lines cut by transversal. In order for, and we have the top is congruent to the bottom. In order for these lines to be parallel, how big would this angle have to be? Well, we know that this plus this have to equal 180 because of same side interior angles for parallel lines cut by a transversal. 180 minus 131 means that we would need it to be 49 degrees. If it were anything besides 49 degrees, we would have an issue. Putting a 49 degrees there makes this parallel, which now they're parallel and congruent, so now we have a parallelogram. So here we see a shape, and the directions say for what values of x and y would the following be a parallelogram. And we see that the shape is just labeled. Nothing's marked, we don't know anything. So that what it's asking us to do is, using our knowledge about parallelograms, what should we apply to force this to be a parallelogram? So if you remember, the diagonals are not congruent and they only give us information about the diagonals. However, the diagonals bisect each other, meaning that these should be congruent. This should be congruent to this. And this should be congruent to this. Congruent means they have equal measure. So that means we now just need to do algebra. It's not really geometry after that. We've already recognized the fact that we have some equal segment lengths. So 7x plus 1 would have to equal 5x plus 3. 3y plus 1 has to equal 2y plus 3. And I go back and forth on how I write my y's. Sorry about that. I try not to make them look like x's sometimes, and sometimes I'm not doing that. Okay, so here we have a binomial equals a binomial. So when I have these, I try to move all my variables to one side and all my constants to the other using inverse operations. So I have to get rid of the adding and subtracting. So how do I get rid of plus 1? I'm going to minus 1. If I subtract 1 from this side, I have to subtract 1 from this side. Now I'm going to take 5x's away from both sides, which will take me down to 2x and 2. And so x must equal 1. Over here, I would need to subtract 1. And subtract 2y. And so we can go ahead and get that answer. So proving polygons are parallelograms or quadrilaterals or parallelograms really comes down to proving information about parallel lines cut by a transversal. If you can use your rules about parallel lines cut by a transversal, you'll be a rock star. You've got this.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.